take a look at this example. Say you have a plantation, all right? You have a plantation, and they do the herbicide spraying. They use the two methods. One is they use that helicopter spraying, okay, helicopter herbicide spraying, okay. The first one, oops. Okay, so this based on your first method, method one. And this is your second method. Use that human herbicide spraying. Use the manpower. Okay, method two. Okay, so we have two different methods. We just do that herbicides. Okay, herbicides in the plantation. Okay, so the method one, the total cost is given. Is a total cost. You see, the one is everything is represent for the method one. Huh? Remember, guys, the total cost one equal to fixed cost one plus variable cost times the quantity. The quantity stand for the number of the plants or the trees is being sprayed. Okay, so this is the formula for that, the method one total cost. Okay, likewise in the method two. So method 2 is a C2 represent, the 2 is represent for the method 2. So the total cost 2 equal to fixed cost 2 plus variable cost 2 times the Q. The number of tree is being can be sprayed. Okay, we're using that herbicides. Okay, now we need to calculate that the break-even point. We're going to calculate how many number of tree can be sprayed. Okay, based on the two method, we optimize it. Huh? Okay, as we know that we equal the both total cost. The total cost, we just make it the equal total cost 1 and total cost 2. So we get this. Okay, the fixed cost 1 plus variable cost times quantity equal to fixed cost 2 plus variable cost 2 times the quantity. Okay, now we just use the algebraic operation. So in order to calculate what is the break even, the number of plants is just nice. Okay, in order to carry out the two methods. Okay, okay. Now, so what I'm gonna do is just very simple. You just need to express. Okay, you just do that the mathematical operation. You just move that the VC2 over here. Okay. And then that FC2 minus FC1, you move to the right hand side. Okay, so now you just factor that the Q, okay, because this is a quantity, the one we just look for. So it's become VC1 minus VC2 equal to FC2 minus FC1. Okay, FC2 minus FC1. Okay, now you easily can calculate. You just bring to that you express the quantity number of 3 in terms of that other variables. Okay, so which means your fixed cost 2 minus fixed cost 1 over the variable cost 1 minus variable cost 2 will calculate the how many number of trees, okay, the trees can be sprayed. So this is that break even point. Okay, break even point of the trees. Okay, okay, so this is how we need to carry out. So every time when you just involve the two different scenario. Okay, like take a look this example. I think you get the better picture. All right, okay, now take a look this the two-way bow saw and then the chainsaw. Okay, so bow saw is the fixed cost is given is a 5 ringgit, and then the variable cost is given as a 40 cents, okay, per tree. That means if you cut one tree, it is they will charge us about 40 cents. Okay, the fixed cost is already given as a 5 ringgit. Okay, if you use the chainsaw, so the fixed cost is given as 305. Okay, but the variable cost is given as a 10 cent per tree. Okay, now we're going to calculate what is that the break-even point for the trees. We can calculate based on that the implementation of the two different methods of that the way in order to calculate that the break-even, the number of trees we can cut in effectively. Okay, now so we just use the same formula, the one how we just developed. Okay, so we take the fixed cost 2 minus fixed cost 1, okay, over so variable cost of that the bore saw minus the variable cost of the chainsaw. So we can get that the break even at the point where the 100 tricks. Okay, so we can able to calculate based on the formula.